So the first kind of causality is Granger Causality test. Earlier, the test was so popular that you cannot imagine. In 2004, when I heard this test first time, so everybody was telling me the Granger Causality test is the number one test in finance, and most of the PhDs, this test is very common test. So anybody who was doing PhD in stock market or between the economic variables, so during that time, Granger Causality was very popular, and you may not believe it that most of the PhDs completed on the basis of Granger Causality. So this Granger Causality test was given by the Professor Clive Granger, who also won a Nobel Prize in the economics. In finance, the problem is that 100% of the theories either come from the economics or they are coming from the quants. So all the theories we are having from other areas. So Granger causality concept is coming from the economics. And what is the concept? I'm telling you. Just see these two graphs carefully. Just see these two graphs carefully, and from the graph we can identify that whenever there is a big change comes in x, whenever there is a change comes in x, on the next day the same change will come in y also, right? So every change will influence y, but on the next day, right? So this is it. Like if you, whenever you analyze the relationship between US and Japanese market, I'm telling you, any positive news in US will also make the positive sentiment in Japanese market. Similarly, if any negative sentiment comes in US, the next day the Japanese market will also be down. So we this kind of relationship is very common in finance and economics, right? So the Granger causality say, if there is a change in exogenous variable having a significant effect on other variable, then this concept is known as Granger causality. So any change in X today, if having an impact on the change in Y tomorrow, then this relationship is known as Granger causality. Now, what is the concept of Granger causality? Let me explain. Yeah. Before that, I am going to explain you the concept of Granger causality with the help of whiteboard, because it will make you more clarity. Yeah. So now I'm going to explain you the logic of Granger causality, and believe me, after this you will have more clarity. We are having two variables here. Let's say yt, which is the endogenous variable, and one is xt. And suppose we want to find out the effect of xt on yt. The one of the problem with Granger causality is that it can be applied between two variables only. You cannot apply Granger causality on three variables. So this is one of the major drawbacks of Granger causality. You can apply only between the two variables. Suppose these two variables are yt and xt. Now if I say this is my step number one, I say that yt means the value of y on any day, and I'm saying that it is affected, it may be affected by the previous value of y. So here I am just applying the AR2 model, dash dash dash, right? So this model is known as AR model. AR model means the y may be influenced by its own previous values. So this is equation number one. So we note down r square, r square, r square. I hope you understand there is a value of r square in regression model. We note down r square of equation 1. We note down equation r square of equation 1. Then in second step, I run another equation, yt is equal to, so I divided this equation into two parts. alpha plus beta 1 yt minus 1 plus beta 2 yt minus 2 and so on. This is the previous equation. This is just the previous equation. But in second equation, I am adding the value of x t minus 1 plus gamma 2 x t minus 2 and so on, right? So this is equation number 2, and I am noting the R2 square of equation number 2. Now after that, I am asking you very simple thing. If I calculate R2 square minus R1 square, so this term is known as increase in R square. This term is known as increase in R square, right? Now the question is that whether this increase in R square is significant or insignificant, right? So what happens if it is significant and what happens if it is insignificant? Now just use your common sense and tell me what this increase in R square indicate. What this R square indicate, right? Okay, the second equation indicate that the yt not only depends upon its own previous values, but also depends upon, also influenced by the past values of second variable. In first equation, we assume that y, so just see the two equations. In first equation, we say that yt only predicted by past values of y. In second equation, we are saying that yt is not only predicting by its own past values, but the past values of x, right? So there are two equations. In equation number 1, we are adding only the past values of y, its own previous legs. In second equation, we are not only adding the past values of y, but also the past values of x. And I am noting the R1 square, R2 square, and I'm taking the difference of 2R square. Now the common sense is telling you that if the past values of x is having a significant influence on y, then this R2 minus R1 square will be highly significant. So this is the meaning which you can analyze with the help of common sense, that in case if y is affected by the past values of x, then R2 is significantly higher than R1 square, and this increase in R square will be significant. So this is the logic of Granger causality. So Granger causality run the equation in two steps. Granger causality run the equation in two steps. In first equation without x, and second equation with x. And we noted down the R1 square of the first equation, R2 square of the second equation, and then we calculate the incremental R square, right? So this is the logic. But in this logic, there is one problem. So what is the problem? That the degree of freedom in equation number 1 is different. The degree of freedom in equation number 2 is different. So we have to adjust by this degree, this equation by degree of freedom. So I will show you the how we can take care of this degree of freedom, and let me show you the formula, exact formula of F statistic. Okay. Now you just see this formula. The formula is here. R2 square, R2 square means the R square of the second equation minus R1 square of the R1 square means R square of the first equation divided by the number of variables in the model. K means number of variables in the model. 1 minus R2 square, and n minus k. N means number of observations. N is the number of observations. K is the number of variables, independent variables. So we calculate F statistic from this formula, and will make the conclusion on the basis of this. So what is the conclusion we can make? I am showing again. Okay, so I just repeat it. I apply yt is equal to past values of y. This is my equation number 1, and I note it down r1 square. Then I run second equation. Y is predicted on the basis of past values of y plus past values of another variable x. This is my equation number 2. I note it down r2 square and then calculate the f statistic, that r2 square minus r1 square divided by k upon 1 minus r2 square divided by n minus k. So now the rule is that if the probability value of f statistic is less than 0.05, then we can conclude as significant causality. So this is the logic of Granger causality, and I will show you first how to run Granger causality in eViews. After that, we will move to the VAR. Okay, let me show the PPT once again. And when you run the Granger causality in software, you will get this kind of result. Now, in first case, just let's read this first. Now, in this case, we are testing the Granger causality between money supply. M2 is the form of money supply and the GDP. Now, M2 is money supply and GDP is the another variable. So we assume that M2 is not causing GDP and GDP is not causing M2. So there are two null hypotheses here, and we check the F statistics, and decision is that because p value in both the cases are less than more than 0.05, here p value is not given, but the software will give you the p value. So we accept the null hypothesis that both are not causing each other, right? So now I am showing you the result of Granger causality, how we can perform Granger causality in eViews, so that we can relate the result with the concept. This is eViews 10, and today I am going to use the data which I shared on the first day, stock indices. So I already shared this data with you, where I have the data of different countries. Let me do it in another way. The data which I shared with you is this stock indices. So one of the way to run it, just select this and click on the drag on the eViews. You can open the exact file. Okay, next. Now we are having the data. Suppose I want to check the causality between Indian markets. I think this is the series of India, and between India and USA, right? And one thing which is very common is that both of the series should be stationary. So first of all, I can make them stationary, but we can make the stationary series in the command also. I select this command, quick group statistic Granger causality. You can follow this command, and these two series are coming, but I am putting d log here. I hope you understand why I am putting d log here, to make them stationary. Okay, so after putting the d log on the two series, the series becomes stationary. Click OK. Now the software is asking you that for predicting any series, how much lag you want to take of another series. So let's continue with the 2, and this is the result we are getting. The result is indicating that in 2 days of the period of lag 2, both are not causing each other. Why? Because the probability value in both the cases are more than 0.05, right? The causality between both the series are insignificant at the lag of 2. So let me try with lag of 3 or lag of more variables. Okay, so let me try for lag 3. T log, again I'm taking, and now I will take the lag 3, and we are again the answer is same. There is no significant causality between the two variables. Okay, so let's do one more try. Can we do this way? Open as a group, view Granger causality. Yeah, but actually it is not true because both are non-stationary variables. So we have to go only that way. Now I am considering only one day, lag 1. I want to check the causality between the lag 1, and I hope yeah, no significant impact is found between India and USA. So let me try between the Japanese market and USA market. Quick estimate equation, Granger causality. I want to check between USA and Japanese market, because both are causing normally each other. D log USA and D log Japanese market. So you can see that to some extent this is found to be near to significant, not highly significant, but near to the significant. Here the result is telling that USA is not causing Japanese market, right? Means there is no causality in the direction of USA to Japan. To some extent we can reject it because this is a borderline case, and the first hypothesis in which we are assuming that Japanese is not causing USA, we are totally rejecting this hypothesis. So we are rejecting the null hypothesis in first case, but we can reject the hypothesis in second case. Let me now I'm taking many series, because you can take 3 series suppose. Now I am taking 3 series to show you what will happen if I apply the Granger causality between the 3 financial time series. D log. Okay, D log Japanese market. And let's do it at lag 2. Okay, so this is the result. Now one thing which you can see here, that either you include 3 variables or you include 4 variables or you include 5 variables, Granger causality can be applied only between the pair of variable, right? Here the software divided the data into different pairs. So first pair is USA and India, where we are rejecting to some extent second hypothesis, but it is we can reject only at 10% significance level. Similarly, in this case, we can reject only at 5% significance level, at 5% significance level. Okay. So here we are not getting the significant causality between the variables. So let me try on another data set. I shared a data set with you today. So let me try that data set. Open foreign data. So today I shared you one data set on which I write the paper. And so let me try on that data set. Reviews workshop data, and I shared you feedback data. In this data set, we are having the data of FII investment, mutual fund investment, and Nifty. This is the data set. We are having the FII equity purchase, FII equity sales, and FII net investment, mutual fund equity purchase, mutual fund equity sales, and mutual fund equity investment, Nifty return, Nifty index. So let me check, can I use the investment? This is a direct investment. Investment means purchase minus sales. This is my purchase, this is the purchase, this is the sales. And the difference between the two is called FI equity investment. Because I am having the 17 years data set in the file, so let me check whether it is a stationary or not. And let me check whether it is a stationary or not. So you can see that FI equity investment is a stationary data because the time period is very lengthy. And let me check mutual fund investment whether it is stationary or not. Unit root we can apply for the purpose. It is also stationary. And then we have to check Nifty return whether it is stationary or not. This is already transformed series, log difference transformation. It is also stationary. So I want to apply the Granger causality between FIA equity investment, mutual fund equity investment, and Nifty return. Then I'm going to open them as a group. Go to view, and I want to apply Granger causality between them with the lag of 2. And here we are getting some significant result. Now you just see the result and how to interpret these result. So let's discuss on this. Number 1. So find out the highest value of F statistic. Highest value is found to be 59. 59. You can see the highest value is 59, right? 59, highest value. So we can say the most strong relationship is in the direction of Nifty to the mutual fund. So there is a significant causality in the direction of the Nifty and the mutual fund. So this is the strongest relationship I found from the result of Granger causality, because F statistic is very high and probability value is less than 0.05. After that, the second causal relationship I found is 51, which is in the direction of Nifty to the FII investment. FII means foreign equity, foreign institutional investment. So this is my first strong causality. This is my strong second causality. And in third case, mutual fund, okay, FII is causing the Nifty, sorry, mutual funds, and fourth, to some extent, mutual fund is also causing FII. So you can check from the first case, both are found to be significant. So we have this kind of relationship, or we can now the conclusion we can write from here. So we are having 3 conclusions. Number 1, or simply Nifty is causing mutual fund and FII. So this is called unidirectional causality. Unidirectional causality means causality is only in the one direction. Nifty is causing them, Nifty is not caused by them. The second conclusion we can draw is the mutual fund and FII have bidirectional causality. Bidirectional means both are causing each other. Both are causing each other. So this is the conclusion we can draw from Granger causality. Now after this, I hope you can understand the relationship between the selected variables. So I hope there is no confusion between this. If you are understanding it, please say yes. And if you are not understanding, Okay, so yeah, so you are understanding it. And but before moving further, I want to explain you something. What is the problems we found? What is the problems in Granger causality we found? Number one, we can take only two variables at a time. We can take only two time series variables in Granger causality. Number two, the selection of lag is not selection of lag, because I can run on lag 2, I can run on lag 3, I can run off lag 4. So selection of lag is still a problem, right? And the third problem that you cannot observe from the answer, but the problem is of indirect causality. Indirect causality. So basically, Granger causality is suffering from three basic problems. We can take only two variables at a time. The selection of lag is not clear, and there is a problem of indirect causality. Indirect causality simply means when A is causing B and B is causing C, then it means A is causing C, right? So this concept may not be true in most of the cases, right? Now I'm giving you example. If US market is causing Japanese market and Japanese market is causing Indian market, so we can explain US is causing also India, right? But this may not be true. It may be possible that US is not causing India. It is because of the relationship between this, right? Or sometimes, okay, now I'm explaining you better. US is a strong country, everybody know that. Whenever some problem comes in US, it is causing Japanese market also. And suppose there is a downfall in the US market, then downfall comes in Japanese market, and downfall comes also in Indian market. Now we are confused that whether India market is influenced by Japanese market or Indian market is coming down because of US, right? So in this case, we should do one thing. We should control US and then see the effect of Japanese on India, or we should control Japanese market and then see the effect of US on India. So this facility is not available in the Granger causality. That's why the all the problems are now solved in a new technique. This technique is called VAR, Vector Auto Regression Model. So let me explain vector auto regression model now. I hope you understand